All right. Newton's second law. I forget who it's named after, but that's the activity we are going to do today. And so what this is an air table, and this is just like an air hockey puck. What we'll do is have it attached to a string with a pulley. There will be some weights hanging off of this pulley. These weights will apply a force that makes this whole entire mass system accelerate, and based on that force and the rate of acceleration, we will figure out some masses here, okay? But what we're doing is getting a force and an acceleration. All right, so the force then, what will be hanging here is paper clips. And then what you see here, I have on the scale 10 paper clips, and those 10 paper clips come out to ish that many grams. To turn that into kgs, you'll move it 3, or if that's 10 clips, then 1 clip is 0.418, right? Move it 3 spots to turn it into kgs, just 0.0, right? Fine. To throw that into newtons, you'll move it over another spot, 0.00418. That's newtons per clip. That's a pretty awkward number, so I just rewrote it as this. So every time I put a paper clip on the end of that string, that's how many newtons it will apply. Cool? So what I'll do is put this one paper clip right there. Come on. And it's hanging off the edge. So it is presently applying that many newtons to this system. And it's not moving because of friction, obviously. And what I'll do with these other 9 paper clips is I will put them on the air puck, just like yay. And then what we'll do for this activity is move the paper clips from here to there. And that will ensure that the mass of this whole system will stay the same throughout this whole activity. So the mass that is being accelerated will be a constant mass. Even though the force is only applied there, it's accelerating the whole system. And if all I do is take clips from here and put them there, then that mass of the whole system stays the same. Next thing I will do is I will show you a distance that this thing travels, and it's ish 62 centimeters. So that delta x, 0.62 meters. And what we said earlier is the number of newtons per paper clip. These two will stay the same also throughout the activity. And that delta x that it travels is what will allow us to calculate the acceleration based on a simplified version of formula, where simply a delta x is 1/2 at squared. So to calculate the a, just rearrange it. 2 times that distance divided by the square of the time, which is what you will be measuring, is the time it takes that puck to slide that distance. So this is the calculation you'll be doing quite a few times, okay? Once you have that, then we'll make data tables and fill them out. But anyway, what we're going to do, you're going to measure the time it takes this puck to slide 62 centimeters, and we are going to start here in a bit with the sounds of physics. All right, so get ready to time this in 3, 2, 1, go. All right, so that was just with one lonely paper clip in here. Is now paper clips. All right, and get ready to time it in 3, 2, 1, go. All right, so we're coming up to 3 clips here, and time it in 3, 2, 1, go. this will be 4. All right, 3, 2, 1, go. This will be 5. 3, 2, 1, go. And 6. 3, 2, 1, go. And 7 clips. All right. 3, 2, 1, go. 8 clips. 3, 2, 1, go. All right. 9. 3, 2, 1, go. And the last. This will be 10. All right, 3, 2, 1, go. All right, so hopefully you measured 10 different times. They, I assume, got smaller every time we added a paper clip. All right, so you have that data. If you need to, just kind of rewind and get those numbers again. So what are you going to do with them? Once you have those numbers, you're going to fill in data tables, and we're going to get graphic. All right, so the data table we'll make is a number of clips from 1 through 10. Then all you'll do is you'll take that number and multiply it by the weight per clip, and that will be your F. So this column is the force that is applied to the overall mass of the system. You guys just measured a bunch of times, so you can put those times here based on those times, and this distance here, you can fill in these accelerations, okay? Once you have those, we can get graphic. The y-sis is where you will put the force in newtons. Again, that's the weight of those paper clips, just the clips that are hanging in. That's the force that is applied. The acceleration then is the acceleration you calculated here based on the 2 delta x over t squared. Once you have that, it'll be some sort of line. It'll look, I mean, it'll only be itself. It will express itself, calculate the slope of that sucker. When you have the slope, figure out what units the slope is in and what that slope represents. And right there, you got a great day, eh? Yay, physics.